Hello, and welcome to IBM Developer. I'm your host, Luke Shantz. In this episode, we're going to be speaking with Andy Meira from the open source Earthquake Early Detection System. Hello, Andy. Thanks for being a guest on IBM Developer.
Hi, Luke. Great to be here. Thank you very much.
Andy, you chose to address earthquakes. Can you tell our listeners and our viewers why you chose to address this problem?
Sure, of course. So earthquakes are something very personal to me. Right now I live in Mexico, and before I lived in Haiti for several years, starting in 2010. So I have very vivid experiences of shaking. It was something I hadn't experienced before I lived in Haiti. And I had the misfortune, you would say, to go through two very significant earthquakes. And then after Haiti in Mexico, I went through the 2017 earthquake where just outside my window on my street, one building fell down and many were damaged. So it was a very personal challenge for me. And I felt that technology was the answer here, that earthquakes, mitigating the effects of earthquakes could best be done by having people as informed as possible.
So there's a lot to unpack here, and I'm really looking forward to digging in this story. But the thing that I found most striking, and I wanted to bring up right away, is the fact that this is an ongoing open source project. So if there's folks living in seismically vulnerable areas, or they just have skills that they want to put to good use, this is a project that is actively being developed that they could get involved with. So let me ask you that. How can people get involved, and what kind of input are you looking for?
Right, great question. So actually, not everyone knows this, but almost a third of the world live in seismically active areas. So that's a lot. And a lot of these people aren't aware that these technologies exist. By that, I mean early warnings for earthquakes. So there's many ways people can get involved. And I guess it depends on what your skill set is or what your interests are. If you are a sort of standard software developer, you can work with our algorithms and you can help us with detecting earthquakes. We have various methods, but we're always trying to improve on them. If you are a hardware guy, you can work on sensors, which is what we deploy to detect. Or you can build your own sensors and deploy them wherever you might live. You know, if you're in Peru, Nepal, Ecuador, Puerto Rico, wherever you may be, you can deploy your own sensors. And finally, maybe you are a front-end developer. Maybe you like creating mobile apps. Well, in that case, you can create the final client device, which people use to receive the alerts.
So I understand why you felt the need, right? You felt the physical mortal danger of earthquakes and where you live. But how did you go from this idea and the impetus to do it to actually creating a project?
Right. So there was a few steps. The very first step was that in Mexico, you would only say that there's maybe 2 or 3 full earthquake early warnings. We call them EEWs in the world. By that, I mean like national systems. And so Mexico turned out to be the first public alert system after the 85 earthquake. And the difficulty was that system was only benefiting government buildings and some schools. And so when I arrived in Mexico, I thought, well, more people should get access to this signal, which gives people a minute, sometimes 2 minutes advance warning, depending on where the earthquake is. So the very first project really was just a little home project I did where I created a box. I had a sort of radio in there which listened to these signals and decoded them. And, you know, through a crowdfunding campaign in Mexico, got those into people's homes. That was the very first step. And then the second step was to understand how that signal was being generated in Mexico and that there was an opportunity to improve on it. And by that, I mean, you know, adding more sensors and maybe not the best quality sensors, these sort of IoT sensors you see behind me, and just having density would mean that we would have a faster response rate and actually more accurate. So that was the next stage. And, you know, that's been an ongoing process for a while now. And those sensors have proven themselves to be very, very effective. So once we put these things together, you know, the next stage really was just to create algorithms because nobody seemed very willing to share theirs with us. So I got together with some scientists at Mexico's UNAM University, and we developed some quite basic algorithms for detecting accelerations that might be earthquakes and not moving trucks. And once we had that going, we just put it in the cloud and it worked. And the cloud was the final piece, you know. We're now moving to the IBM cloud, which offers everything we need. And the idea there is that, you know, you can have an early warning system anywhere in the world and as long as you mimic the services that we've created and ideally improve on them as well, it will just work.
If I'm hearing this now, I'm a developer or an enthusiast, and I want to participate, I want to get involved. Where should I go? What should I do?
Great. So everybody is super welcome. And I think the first call would be to go to openeew.com. And openeew.com is the project website, the documentation website for the project, OpenEEW, which is all of the core technologies that Grillo has provided now with other people's assistance as well, including IBM, including Linux Foundation. These technologies now sit inside of their own repositories in GitHub, which are sort of very public, very open, and there's lots of movement happening there. So we would encourage people to go there and see what you're interested in. You know, if you are an electrical engineer in Japan, I think you might straight away go to the sensor repository, and you might say to yourself, "Oh, look, they're using an ESP32. They're using this form of accelerometer. They're using an optional GPS module. But why aren't they using a cellular connection for areas that are very rural, or with poor local internet?" And then if you are a data scientist, you'll probably go to the detection repo and you would say, okay, they've got a Node-RED option and they've got a Docker image. I think we should be incorporating this method using this type of model. So it really depends on what people are interested in. But we're still working on the documentation. I think there's still a bit of work to do. But for now, there's quite a few things in there, and I would encourage people to have a look. And it really depends. I think you made a good point, because not everybody has felt an earthquake, but we've all seen it in the news. So maybe you're not the guy installing the sensors. Maybe you're not the guy, creating an array. Ideally, we would love those people to come on board, and not just one, but ideally 2, 3, or 4, because that's when you can start to triangulate earthquakes. But ideally, we have people who not just do the sensors, but help us with everything else, because that stuff lives in the cloud. And as long as we have data coming from our networks, which already we have in Puerto Rico with Pedro Cruz, and in Mexico, and in some in Chile, we have a couple in Costa Rica. We've just sent some to New Zealand. And so this is growing slowly, but we could always have more in those areas and others. But now the data lives in the cloud, anybody can play with it.
So interesting. And I just to pull one thread of what you said there, this decentralized low cost theme, which is parallels what we've seen happen with the cloud, right? You can have all different types of offerings and really minimize. You don't have to have some bare metal dedicated server anymore. It could be serverless functions, VMs, all sorts of things. The other thing I was going to mention, and this is the second time I'm mentioning this in a podcast, it seems to be my theme, but one of my favorite films ever is this Errol Morris documentary called Fast, Cheap, and Out of Control. And what it's referencing, the title references a paper from MIT researchers. And the idea was, instead of making this, $500 million behemoth that if something goes wrong, you've lost everything. Why don't you make $1 million nodes, and then you've got this sort of decentralized swarm model. And then maybe 2 weeks ago, I was interviewing Naeem Altaf, the IBM Space Tech CTO, and he tells me that they're working on open source CubeSat swarming technology with this exact same mentality, where it's like, hey, we're going to put up all of these small CubeSats. They're going to have a variety of sensors across them. And then the same way you build a cloud application where you say, hey, I need this, and this. It doesn't matter where it is. I'm just going to connect them. And this abstraction is now my device. Satellites can be called this way, where you say, like, hey, I'm going to define the instrumentation that I need across these nodes. Anyway, so that was a little bit of a tangent, but I'm seeing this strong theme, and it's amazing how powerful it is.
Yeah, you put up some good ideas there. Yeah. So, the comparison might be unfair towards SpaceX, but we do think of ourselves as having a parallel there, insofar as SpaceX took what was a government project, a very expensive government project, and optimized it for the application. And I think we are doing in our own sort of small way a very similar concept, and so I think there's a lot of opportunity to take these huge monolithic projects and break them into little pieces. And of course, the example you mentioned is a good one, because if you have more devices on a network, you have redundancy. And I think when you're talking about mission critical issues, you need redundancy. If one fails, you need another one to take over the work. So it just felt very obvious to us that a redundancy model would be much better. And cost is everything, especially, one thing that really mattered to us is, where do earthquakes kill most people or create most damage? Well, it's in the developing world, because in the developing world, you have poor construction and you have maybe weak emergency services. And so, we had a magnitude, I forgot the number, but let's just say a magnitude 9 in Japan in 2011, just after the Haiti one, which was only a 7.2 or 3, depending on who you look at. And yet the Japanese one had far fewer fatalities because buildings resist, they're very well made. Whereas in Haiti, you have a sort of poor self-constructed housing built with, often they don't use enough reinforcement bars, or the cement mixture doesn't have enough cement in it, the concrete mixture. And so those buildings are like to fall. So those countries that need these systems the most, warning systems, can't afford it. So economy is everything if you're really going to help people. And getting the price down, redundant systems, doing it in phases, maybe not doing the whole country at once, but starting with a city and alerting through, nearby earthquakes. That seemed to be our approach.
That's really interesting. And the point you made about Japan, I had heard this as well, that there's very strict building and regulation codes. So things are being rebuilt every 20 or 30 years as the code changes. And they've got all this, like you're saying, cable systems in the buildings to make them and reinforce concrete and all kinds of, I'm sure, foundation things that I don't know about. But what I think is so interesting about when you talk about the data is, it also it creates these pointers to other things, right? Like, hey, this happened here and this happened here, and if we have that data, we can actually find these other root causes.
Yeah, exactly. So I think we're already starting to see the side benefits from this when Harvard University came on board, because we've been publishing the data for a long time for free using the sort of open data platform, but we hadn't really known why we were doing it. It just felt like the right thing to do. It felt like we had data. Other people might have more value in this than we have. We're just using the data really in real time as it happens. Is there an earthquake or not? And then we just sort of park the data somewhere. So we thought, well, let's put it in the cloud and see if someone benefits from it. And we've had a lot of researchers using this. So there has been some benefits. And I think... I think there's a real opportunity to overlay different things on top of this. And one thing that, in our particular field that we're aware of is that there's a lot of opportunity to engage different types of people. So I think, how people use this technology depends really on where they are. And so, a municipality might be interested in a warning system because it will give them some sort of historic understanding of which areas in their municipality is more susceptible to shaking than others. We can provide that. Someone who has a manufacturing plant might know if they're vulnerable in a way that they didn't know before, and make business decisions based on that. And then, of course, citizens might just sort of feel safer or know more about the shaking in their area. So there's an opportunity. And open source really is the way we can get into this. I think there was always this immense sense of mistrust in the community of EEWs. I think when I entered it, I wanted to speak to everybody, and I you can find it on the internet. The Mexican system, the Shake Alert that's been built in the US that we have had some contact with, the system in Japan. So I sent emails all over the world. And I think a lot of people were very sort of siloed, as you said, within what they were doing. And sharing isn't necessarily part of what people do here. And it felt like everyone was developing the same tools just on their own. So standardizing, I thought, was the right method. So whilst we haven't necessarily replicated every other system there, we have taken the same principles, shaking, detect it, and then send alerts. And we've tried to find a way to sort of standardize this and package it up. And hopefully people will come in now, maybe someone listening to this podcast, and they will help us on that journey, or maybe take us in a slightly different direction. That's really the opportunity.
Well, Andy, thank you so much for taking the time to chat. This has been a fascinating conversation. I'm a IoT guy, so I sort of geek out on the hardware, but it's really opened my eyes to new aspects of how open source and these, public, corporate, and individual collaborations can play out. In closing, though, let me ask you: is there anything I didn't ask you that I should have, or any closing thoughts you have for our listeners and viewers?
I would just really drive home this point about contributing, and if anyone was interested in what they listened to go to openeew.com, and that there really is this incredible opportunity for many different people. We cater for every skill set in this sort of development community, and we would welcome everybody.
Excellent. Well, I'm definitely heading there right after this call, and I'm going to get involved myself. So thank you so much, Andy. Looking forward to seeing the future of this project. Thank you.